to MEC4406 and I'm Daniel Reynolds. I want to demonstrate my 2 degree of freedom robotic arm for reaching any spot on a 20 by 20 square board. Now, if we click run, we can get randomized points to check to see whether it is functioning correct without hard coding in. Otherwise, there are over 400 combinations. Now, my original idea that I wanted to have a go at putting the arm in the central location right here. Now, originally my thinking is using the first quadrant and then creating it similar to what I've just showed you, and then mirroring it around with all of the parameters based on before. Now, it proved very difficult to try to grab that concept, and it started to select over here and it would mirror and then have that thing. So I thought, I don't have enough time to play around with that. So let's go back to doing it as this. And then I thought, hang on, why can't I use the global arm to drive my central arm? So now we have a central arm. Now that can just run as code. It doesn't have to be an arm. So as we see up here, we have my original one here, 210. Now we just scaled it up to 420 and it all reaches fine. So we have no error. Now, just to check that, we can move these little sliders down here and select for any solution you wish. Yep, see, to prove that this thing will not break. Very good coding, it quite reliable. So we could switch either of these off or on. And let's have a look at our code. So I've chosen Python because it's very intuitive. I have a lot of experience with it, and it's great for detecting any errors. So we have a global variable, so we can really easily see and change things without diving down into the code. Comment out very nicely. There's a lot of help online that if you get stuck on what others have done in certain situations. Yeah, so very simple coding, very clean. Despite the capabilities, you can see the code isn't very long. It's very simple. You got the main part of the code you can see quite clearly, lots of comments. Okay, so let's now talk about our construction. So originally, to calculate and to find out what to do, I use SolidWorks to just draw up something. So this would have been the quadrant. Let's have a look at some of the spots to reach. Now I realize from here to here could have been an issue. So I just made sure that the angles I used is not going to interfere. So that gave me some insight, but just by sketching it out and driving it with things. So I had to play around on numbers and Mac numbers. So having a look at just our simple cosine rule and how that may work. And then I could see for any solution in what can, before I start programming. Okay, so for my construction, the task hasn't asked to model it, but I thought I'd base it on a robot I've designed before. I'll go to the other picture first, the top side. So what we would have with the long arms, I'm worried about the deflection, and I've had a calculator of that as well. So ideally, we don't want the servo motor over there, and we don't want to hang all of the construction of the servo motors. So I'm relying on these big heavy bearings, what I've done before. So you can imagine the housing supporting that, and despite any deflection, it's not going to interfere with any of the logics or the potentiometer sensors. For here, we'll have a belt driving the arm. So we're pulling this right back over here, so we don't have to wait. And then we have our laser pointer over here. So this is made in either resin or ABS plastic. Okay, so a bit more of a closer view here. You can see how we have the bearing. This is another way we can drive it. So we'd have on like a slew ring. So instead of moving our arm moves riding on this motor here. So that part is fixed, and then we can slew that around. This is a very sturdy construction. And as you can see, my other motors don't directly couple the servo motors in order to protect them. Now I have a Raspberry Pi Pico, very fun to work with. I have even a BLE, so I can control this remotely without any plug-in. So I have a MOSFET that I will use to power the servos, so I'm not directly running from the Pico because it will draw too much power. Also, the power pack will not, the MOSFET will allow that to make sure that it doesn't flow back into the Pico or ruin your computer as well.